Hello everyone. Today here we start with part 4 of number system. Last day we have done the decimal representation of rational numbers. Today we start with the decimal representation of irrational numbers. So what is the decimal representation of irrational numbers? Decimal representation for irrational numbers are non-terminating and non-repeating. Like for example, if I take, like last day we have, if you remember, we have given a chart where I have shown you that decimals are actually of two types. The first one is terminating, I'm writing in short. Okay, so terminating, and this is non-terminating. This was rational numbers. And this was of two types. First is repeating and the second was non-repeating. This was rational number and this was irrational number. So irrational numbers are non-repeating and non-terminating, which will obviously be in forms of decimal. Like for example, if I am taking root 2, as we know that squares and cubes of imperfect cubes or a cube or square of any number are actually rational numbers. So root 2 is an irrational number because 2 is not the perfect square. We all know to calculate the value of root 2 by the square root method. So 2 can be actually written as 2.00000. Numerous number of zeros can be there, and we are pairing the zeros together. Now what is the first number here? 2. We can write this as 1, 1s are 1. This is 1 upon 0, 0. This is 1 in the quotient, multiply 2 will be equals to 2. Now 22 into what number should be written over here? If I find out 24 into 4, it's coming 4 4s are 16, 8 plus 1 9. If I'm doing 25 into 5, it will come 25, 5 2s are 10, 11 12, 125. So it's exceeding 100. Whatever number you are adding with these numbers, we have to multiply the same number over here also. So actually it will be 24, and point is there, so here has to be a point before you put the zeros down. So 1.4, and here the number will come 96. So 100 minus 96, we will get this number as 40. 4 and another 2 zeros will come down. So 400. So again we multiply 14 into 2, that is coming 28. Ignore this point, decimal point, as you multiply over to this side. Again 281, 1 will be equals to 281. We'll get over here 119, another 2 zeros will come down. Again 141 into 2 will be equals to 282. If you put 4 over here, we'll get over here 11296. Again this will be 604, another 2 zeros will come down. In this way it will be never ending. So root 2 equal to 1.414. In this way it will move on. We don't know what is the exact number where it will end and what is the pattern of repetition. Is there any pattern of repetition after this number? The next number which we will get is 2. Because 1414, if you multiply this, we will get this as 2826. We have to put 2 over here and another 2 over here. So after this, the number which will come is 2. So you can see over here there is not a particular pattern of repetition, and also it is a non-terminating. So irrational numbers are actually non-terminating as well as they are non-repeating. Hence why they are termed as irrational numbers. So this is the decimal representation of irrational numbers, which is non-terminating, it will never terminate, it will move on up to infinite times. And non-repeating means we don't know what is the exact way of its repetition. And so therefore we are concluding that we have learnt about the decimal representation of rational numbers and irrational numbers. The next very interesting part actually of irrational and rational number is that, especially it is actually an irrational number, and it's a Greek word that is pi. We all know this as the number pi. Pi value is actually, pi is, you know how we have got pi? We all know that how a circle is drawn. What is the center? If this is the radius of the circle, what will be the circumference of the circle? 2 pi r. And what is diameter of a circle? Twice of r. Easily you can see, if I'm dividing c by d, circumference of a circle, by diameter of the circle, we will get 2 pi r by 2r. That will be equals to pi. So you can understand this thing. Pi is actually the ratio of the circumference and diameter of any circle. If you put any value of radius of a circle, you will get the value of pi, which is around 3.14. This is experimental value and this is proved. You can also do it on your own. Like if I'm giving you, you can do at your home. If I'm taking r is equals to 1, suppose if you are drawing a circle of radius 1, so what will be the circumference of a circle? And pi, for mathematical calculations, we take the number as 22 by 7. This is the number which we take for our easy calculation, and this is the main approximated value of pi. Why this happens, that we will come later on. First and foremost, let us check whether pi value is approximately coming this or not by taking this value. So circumference will be 2 into 22 by 7 into 1, that is coming is equal to 44 by 7. And what about 2r? Diameter is 2r, just now we have done. So diameter is equals to 2r, that is equals to 2 into 1, that is equals to 2. So what will be the value of pi? C by d. If you do 44 by 7 into 2, that is 44 by 14. That will come around 3.14285. This is for r equals to 1. If you take for r is equals to 19, so circumference will be equals to 2 into 19 into 22 by 7. That is coming as equals to 119.428. You can check with calculators also. And diameter is equals to how much? It is 2r. So 2 into 19, that is equals to coming as 38. So what will be the value of pi over here? Pi is equals to c by d. That is 119.428 divided by 38. And that is equals to 3.142842, somewhere like this it will go. Can you see one thing? That whatever values of r you are putting, pi value is exactly equals to 3.14, then 285, but the first two numbers after decimal point remains unchanged. That is why whatever value you take, the value of r, maybe 1 crore, 1 million, 2 lakhs, 24/7, any number if you take as the value of r, you can check in your homes also by taking various values of r. You will find that all the time the value of pi will be approximately equals to 3.14. But we take the value of pi as 22 by 7 only for making the calculations easy. So the actual value of pi is exactly equals to 3.141592653589793238 ... You can easily see that this is never ending, it is non-repeating and also non-terminating. So therefore, we cannot use such a big value for any calculations or higher mathematics. Therefore, we represent it or we approximate it as 3.14. So to simplify the calculations, we take pi is equal to 22 by 7 just for mathematical calculations, nothing else. But 22 by 7 is not the exact value of pi. 22 by 7 is actually the irrational as because we know 22 by 7 is a rational number because 22 and 7 both are integers. So 22 by 7 is the rational representation of pi. Is the rational representation of pi. 22 by 7 is the rational representation of pi. So pi is actually, we will call it an irrational number. So pi is actually an irrational number because its value is approximated as 3.14. 22 by 7, if the number is given, so if the question is given that which is rational and which is irrational number, suppose the number is given, suppose question is given that you have to say that which is rational number and which is irrational number. Examine which is rational and which is irrational. 22 by 7 will be obviously a rational number because it's in the form p by q and it's in simplest form. Whereas pi is always irrational number because exact value of pi is 3.145926. So this is approximated as 3.14. So this will be an irrational number.